Question 1. We are asked to solve for x in 1.1.1. We're having 2x minus 1, x plus 5 is equal to 0. So we are having 2x minus 1 and x plus 5 equals to 0. So to solve for x, we're going to say 2x minus 1 is equal to 0, or x plus 5 equals to 0. Then you say 2x is equals to 1, or x plus 5 equals to 0. Then we divide by 2, and x is equals to 1 over 2, or x is equals to minus 5. So this is the solution for 1.1.1. 1.1.2, we are given this expression here, which is equals to 0. And if we are given a statement saying that we must leave our answer to 2 decimal places, that tells us that we can only use a quadratic formula to solve for x for this expression. So we're having 7x squared plus 5x minus 9 is equals to 0. So to solve for x, we use a quadratic formula, which is minus b plus or minus root of b squared minus 4ac divided by 2a. X is equals to minus, our b is equals to 5, so it's plus or minus root of 5 squared minus 4. Our a is 7, our c is minus 9. Then we divide by 2 into a, which is 7. So we're gonna leave our answers to 2 decimal places. So the first solution of x in decimal is 0.83, or x is equals to minus 1.55. So these are your solutions of x. 1.1.3, we are asked to solve for x squared minus 16 greater or equals to 0. So we're having x squared minus 16 greater or equals to 0. The first thing we're going to do is factorize this difference of 2 squares. And it's the factors of x squared, it's x, and the factors of 16, it's 4 and 4, so it's going to be plus and minus. Then our critical values is going to be x being equals to 4, or x being equals to minus 4. So these are your critical values. So what you're going to do is you're going to go to your number line and represent your critical values. So you have minus 4 as your critical value, and you have 4 as your critical values. So what you're going to do is you're going to test values before your critical value. Let's say it's minus 5, or after your critical value, which let's say it's going to be minus 3, and after this critical value, which let's say it's 5. So you're going to test these values here by putting them into your original equation. And we are more interested in the signs that you get, not necessarily the solutions, then the numbers, right? So you will find that when you substitute any value before this critical value, before it, which can be minus 5, minus 6, minus 7, you're going to get a sign that is positive. And then if you substitute any critical value that is within minus 4 and 4, you're going to get a sign that is negative. Then if you substitute any value that is greater than 4, which can be 5, 6, 7, or 8, any value that is greater than 4, you will get a solution of y which is positive. So, but you need to remember that the question says that it needs solutions of x such that the solution of y is greater or equals to 0, meaning that the solution of y has to be positive or just be equal to 0. So we look at our signs. So by looking at our signs, we can see that here are the solutions of. So we look at our signs. So looking at our signs, we can see that the solutions of y are positive here and positive here. So to conclude, you will use your critical values and direct your solutions of y to to the signs which are positive. So meaning that the directions will look there and another direction will look towards the positive solutions of y. So we can simply conclude and say x must be less than or equals to minus 4, or x must be greater or equals to 4. So these are your final solutions of x when y values are positive. So now we're going to solve 1.1.4. We solve for x for this expression here. So we're having 3 to the power 2x plus 2 multiplied by 3 to the power x being equals to 3. So what we're going to do is we're going to transpose the 3 to the other side, and we're going to have 3 to the power 2x plus 2 times 3 to the power x minus 3 is equals to 0. And looking at this problem here, we can because we have 3 exponents and have 2, and the common bases that we have here, it's 3 and 3. So the exponents, as you can see, it's 2x, it's x. So we can simply say that let k be equals to 3 to the exponent x, right? So meaning we're gonna have, where there's 3 to the power exponent 2x, we're going to say k squared plus 2 multiplied by k minus 3 equals to 0. And then we factorize this problem here being equal to 0. The factors of k squared is k, and the factors of this minus 3 here is going to be 3 and 1. Then the middle term will take this the sign, the bigger number, will take the sign of the middle term, so it's positive, so we're going to write positive, and then here we'll write negative. So then k will be equals to 1, or k will be equals to minus 3, but we must remember that k is equals to 3 to the power x. So meaning, where does k, just gonna put back 3 to the power of x being equals to 1, or 3 to the power x being equals to minus 3. So here we have a base of 3. We can make this one to be base of 3. So we have 3 to the power of x equals to 3 to the power of 0. And then to conclude, we can say, or before we conclude rather, looking at this one, the bases are not the same. We have 3 to the power of x, the base is 3, but here the base is negative 3. So here there's no solution. So to continue for this problem here, we can simply say 3 to the power of x equals to 3 to the power of 0. So same base, you drop the exponent, so x is equals to 0. So that is your final solution for this problem here. So now we're going to solve 1.2. We're solving for x and y simultaneously. So we're having a problem here which is x minus 2y is equals to 1, and 4x squared minus 3xy is equals to 5 plus 4y. So we're going to write our equations, which is x minus 2y is equals to 1. So this will say it's equation 1, and we have 4x squared minus 3xy is equals to 5 plus 4y. Let's say this is equation 2. So we're going to create equation 3 using a simpler equation here, which is this one here. So we're going to say x is equals to 2y plus 1. So this would be our equation 3. So what we'll do is we'll substitute equation 3 into equation 2. So where we see x, we're just going to put 2y plus 1. So it's going to be 4 into 2y plus 1 squared minus 3 into 2y plus 1 multiplied by y is equals to 5 plus 4y. So what you're going to do is we're going to solve this problem here, which is 2y plus 1 squared is equals to 2y plus 1 and 2y plus 1 to find the product. So we multiply using FOIL method. So 2y multiplied by 2y is going to give us 4y squared, and then we multiply this, giving us plus 2y, and this one here plus 2y plus 1. So it's going to be 4y squared plus 4y plus 1. So we'll have 4 multiplying the 4y squared plus 4y plus 1, and minus 3 into 2y plus 1 multiplied by y equals to 5 plus 4y. Then the 4 will multiply everything that is inside. So we're gonna have 16y squared plus 16y plus 4, and then multiplying the 3 inside here, we're going to have minus, but before we multiply the 3, let's multiply the y first. The reason is I want to avoid this sign at the moment. So we're going to have minus 3 into 2y squared plus y equals to 5 plus 4y. So it's 16y squared plus 16y plus 4. Then the minus 3 will multiply everything inside. So we're going to have minus 6y squared minus 3y is equals to 5 plus 4y. So you're going to have 16y squared minus 6y squared plus 16y minus 3y. Then you transpose the minus 4 to the other side, you have minus 4y. And then you're going to collect like terms for this one. Didn't notice it, this one and this 5 here. So it's going to be plus 4 minus 5 being equals to 0. So now you're gonna write everything. You're gonna add or subtract rather all the like terms, and you should have a standard form of 10y squared plus 9y minus 1 being equals to 0. Then from here we factorize our problem here. So it's gonna be 10y, the factors of 10y squared, and then here we're gonna write y, and then the factors of 1 is simply going to be 1, and then we write the sign because you're having 10y here, meaning the middle term is 9. So if we can just make this part positive and this part negative. So to solve this, we're going to say 10y minus 1 equals to 0, or y plus 1 equals to 0. Transpose the 1 to the other side, we have 10y being equals to 1, or y being equals to minus 1, and divide by 10, we have y being equals to 1 over 10, or y is equals to minus 1. So we're having a solutions of y. Now we need to identify the solutions of x. So we're going to go back to our equation here and try to remember what was our equation 3. So it was x being equals to 2y plus 1. So you're going to write the equation here. So we're going to say x. So we're going to say x is equals to 2y plus 1, or x is equals to 2y plus 1. So you're going to substitute your values of y. So you're going to say x is equals to 2. Our y is 1 over 10, and then plus 1, or our x is equals to 2, and then our solution of y is minus 1 plus 1. So the solutions of x, the first one is going to be 6 over 5, or x is equals to minus 1. So these are your solutions of x, these ones, and these are your solutions of y. So now we're going to solve 1.3. 1.3.1 says that solve for x in the following equation. So you're having this expression here and you're asked to solve for x. So what we'll do is we're having x plus 5 and x minus 6 being equals to 26. So to solve for x, we first have to find the product. So it's going to be x minus x. So to solve for x, we have to find the product. So what's going to happen is we'll multiply using FOIL method. So we're going to have x squared minus 6x plus 5 So to solve this problem here, we need to first apply our FOIL method. So x multiplied by x is going to be x squared. X multiplied by this 6 here is going to be minus 6x. And then the 5 multiplied by x is plus 5x. 5 multiplied by minus 6 will give us minus 30, being equals to 26. So we're going to transpose the 26 to the other side. We have x squared minus the like terms, we add them together, we're going to have minus x, and then minus 30 minus 26 being equals to 0. So you're going to add this minus 30 and this minus 26. So we're going to have x squared minus x minus 56 being equals to 0. So we're going to factorize this problem here. We're going to factorize, find the factors of x squared is going to be x, and then find the factors of 56 such that when you add or subtract, they give you the middle term. So it's going to be 7 and 8. So our 7 is going to be positive, 8 would be negative, since the larger number will take the sign of the middle term. So it's going to be equal to 0. So x plus 7 is equal to 0, or x minus 8 is equal to 0. So x will be equals to minus 7, or x is equals to 8. So these are your solutions of x. Okay, so 1.3.2, the question says that hence or otherwise determine the values of x if f of x is equals to x plus 5, x minus 6, and f of x lies between 26 and 0. So remember that the first solution, our f of x was equals to 26. So that was the first problem. F of x was equals to 26, and we found the solutions of x when f of x was equals to 26. So now we're going to equate our f of x to be equal to 0, so that we find the solutions of x, and then we determine the solutions of x that lie between those problems. Now for f of x being equals to 26, our solutions of x was x being equals to minus 7, or x being equals to 8. So now f of x equals to 0. So let's find solutions of x for f of x equals to 0. So our f of x, we know very well that it's x plus 5 and x minus 6. So our solutions of x for this problem is x equals to minus 5, or x being equals to 6. So these are the solutions of x. So now we're having solutions of x for this one and solutions of x for this one too. But remember, the questions told us that f of x lies between 26 and 0. So our conclusion would be x must lie between the initial solutions of x, which is this one and this one here. So it's minus 5 and minus 7, or x must lie between the final solutions of x, which is 8 and 6. So it's going to be 6 here and 8. So these are the solutions of x which lie between the initial solutions of x and the final solutions of x. Now question 2 says that we are given this quadratic pattern of 12, 21 and 34. So the first question says that we must write down the next two terms that follow. So we're having our quadratic pattern of 12, 21 and 34, and we want the next two terms, right? So what we're going to do is we're going to find the difference of these two terms. So 21 minus 12 is going to give you 9, and 34 minus 21 will give you 13. So we know very well that the second difference of our quadratic number pattern is constant, which if you minus 13 and 9 is going to give you 4. So we know very well that it's just going to remain constant. So the next term, if you want to identify, here, we know it's going to increase by this 4 here. So it's going to be 17 because 13 plus 4 is 17. Then 17 plus 4 is going to give you 21. So now to find the next term, which is this one here, we're going to say 34 plus 17. It should give you 51. And 51 plus 21 should give you the following term, which is 72. So these are the next two terms of the sequence. Now, 2.1.2, we are asked to determine the formulae of the nth term of the number pattern. So remember that we are having our quadratic sequence written like this, and we found two terms, so 51 and 72. The difference between these terms here, it's 9, 13, 17, and 21. So we know that the second difference is constant, which is 4. So to find our formula, we're going to say this is equals to 2a. So 2a is equals to 4. Divide by 2 both sides. We're going to have a being equal to 2. And then to find our b, is going to say 3a plus b is equals to the first term of your first difference, which is equals to 9. And we know our a is equals to 2 plus b is equals to 9. Then our b should be equals to 3 if we transpose the 6 to the other side. It's going to be 9 minus 6. Then a plus b plus c is equals to the first term of the quadratic pattern, which is 12. And our a, we know it's 2 plus our b is 3 plus c is equal to 12. We add the 2 and the 3 is going to give you 5. We transpose to the other side, so you should get c being equals to 7. So now you have our a, b, and c values. So our nth term, we know the standard formula is equals to a n squared plus b n plus c. So we're going to substitute the values. So our a is 2, so it's going to be 2n squared. Our b is 3, so it's going to be plus 3n. Our c is 7 plus 7. So this would be our nth term. So now 2.1.3 says that calculate the value of the 60th term of the pattern. So the 60th term of the pattern, so we're going to use the previous nth term that we calculated. So we know very well that our general term of the quadratic number pattern is equal to t. N is equal to 2n squared plus 3n plus 7. And we want t of 60. Right? So which means where there's n, we're going to substitute 60. So it's going to be 2 into 60 squared plus 3 into 60 plus 7. So you use the calculator. The solution you should find is 7,387. 2.2. Consider the following finite arithmetic series. So when they say finite, which means that it has an end point. Infinite means it is continuous. So this one, it has an end point, which is 172, which is the last term. So 2.1 or 2.2.1 rather says that calculate how many terms are in the series. So if you look, we are told that this is an arithmetic series. So we're going to use the standard formula, or the standard or the general term rather of an arithmetic sequence. So in this sequence, we know the difference is constant since we are told that it's an arithmetic sequence. The first term of this sequence, our a, is equals to 4, and the difference is 7 minus 4 will give you 3, and 10 minus 7 will give you 3. So we know our d is equals to 3. So we're going to use Tn is equals to a plus into n minus 1 multiplied by d. So this is the formula that we're going to use to find the value of n. So our general formula for an arithmetic sequence is Tn is equals to a plus n minus 1 d. And we are given Tn, which was the last term, it's 172. and the first term is equals to 4 plus into n minus 1, and our difference is 3, difference of the sequence. Then we transpose the 4 to the other side. We're going to have 172 is equals to, then the 3 will multiply every value that it finds inside. So we're going to have 3n minus 3. We know here it's supposed to be minus 4, right? And then we transpose the 3 to the other side. We're going to have 3n is equals to minus 4 plus 172 plus 3. Then we divide by 3, we divide by 3 everything. So n should be 57. 2.2.2, determine the sum of the series. So you already know a being equals to 4. You know the difference is equals to 3, and you know the n value is equals to 57. So you're going to use the formula of the sum of an arithmetic series, which is n over 2 into a plus l. So the reason why you're using this one is because you already have the last term. So you can also use the other one, which is Sn is equals to n over 2 into 2a plus into n minus 1 multiplied by d. You can also use this one here. So using our sum formula, which is n over 2 into a plus l, and you know it's sum of 57 terms. So 57 over 2 into our first term being 4, our last term being 172. So the solution here is supposed to be 5016. 3.1.1, we are asked to write down the first 3 terms of the series. So the first thing we're going to do is we're going to write our sum. So we are given our sum, which is 12 at the top and k being equals to 3. So it's 4 into 1 over 2 to the power of k minus 1. So to find our first 3 terms of the sequence, or the sum rather, so we're going to say k. When k starts at 3, we're going to substitute into this problem here. It's going to be 3. So let me write it properly. So it's going to be 3 minus 1, and the answer for this one, you need to get 1. And when k is equals to 4, it's going to be 4 into 1 over 4 to the power of 4 minus 1. And the answer to this one should be 1 over 2. K is equals to 5. 4 into 1 over 4 to the power of 5 minus 1. You should get 1 over 4. So punch this calculator to find your next 3 terms. So the next 3 terms of this problem here, it's 1 plus 1 over 2 plus 1 over 4. So 3.1.2 says that calculate the sum of the series. So the first thing you need to do is we need to identify the values that we found in 3.1.1, which are our first 3 terms of the series, and also define whether the series is arithmetic or geometric. Then we can use a formula of that series to find the sum. Remember that our sequence, or the first 3 terms, were 1, 1 over 2 and 1 over 4. So if you can see here, these terms are in fraction form. Okay, that doesn't really define on whether or not it's an arithmetic or geometric. So let's first find the ratio of these terms here and see whether or not they are geometric. So T2 over T1 is equals to T3 over T2. So T2 over T1, it's 1 over 2 divided by 1 equals to 1 over 4 divided by 1 over 2. So if you punch your calculator, you will find that R is equals to 1 over 2. So we're having a constant ratio of 1 over 2. So therefore, this is a geometric series. So meaning that we're going to use a geometric sum formula. So our A value is equals to 1, which is this one here. Our R is equals to 1 over 2. So we're going to find our sum But before we do that, we need to identify the number of terms of this sequence here. Remember that the sum that we were given initially in the problem, it was sum of to the power 12 when k is equals to 3. So to find the number of terms, we say n is equals to top minus bottom plus 1. So the top, which is this one here, is going to be 12 minus the bottom, which is 3, plus 1. So our n is supposed to be 10. So now we have our n value being equal to 10. So we are able to find the sum of the series. So now the formula for a geometric sum is Sn is equals to a into 1 minus r to the power n divided by 1 minus r. So our a value is 1 into 1 minus our r is 1 over 2 to the power of n, which our n is 10 terms, divided by 1 minus 1 over 2. So you're going to punch your calculator and the solution should be 1.998. So 3.2, we are given this series here, which is cos of theta plus sine of 2 theta plus 4 sine of squared theta multiplied by cos of theta, where theta is an acute angle. So 3.2.1, we are asked to prove that this it is actually a geometric series. So the characteristics of a geometric series, we know that it must have a constant ratio throughout. So meaning that the ratio of T2 over T1 must be equal to the ratio of T3 over T2. So in the problem here, we are given cos of theta plus sine of 2 theta plus 4 sine squared theta multiplied by cos of theta. So as I said, we're going to use this formula here of our constant ratio. So constant ratio is equals to, so this would be our first term, this would be our second term, and this would be our third term. So T2 over T1 is equals to T3 over T2. So T2 is sine of 2 theta divided by T1, which is cos of theta, being equals to T3 is 4 sine squared theta multiplied by cos of theta divided by sine of 2 theta. So this is our R. So to write this properly, we're going to say sine of 2 theta over cos of theta is equals to 4 sine squared theta multiplied by cos of theta divided by sine of 2 theta. So what you need to note here is your double angles. So this one here, your sine of 2 theta. Sine of 2 theta, if you remember your trick, you know it's equals to 2 sine theta cos theta. And same applies to this one here. So what you're going to do, you're going to replace it with that problem here. So you're going to say this sine of 2 theta, it's actually 2 sine theta cos theta. Then you divide with your cos of theta being equals to 4 sine squared theta multiplied by cos of theta divide by your 2 sine theta cos theta. Remember this, same as this one. So now you'll be able to solve your problem. So cos of theta cancels out or divide through with that cos of theta. This cos theta divides with this one, and this one divides with this one, but sine theta remains. So meaning we're going to have 2 sine theta on our left being equals to this 4 sine theta divided by 2, right? So the 4 will divide the 2, therefore our final solution 2 sine theta will be equals to 2 sine theta. So if you can see that the left hand side is equals to the right hand side, so the ratio R is actually constant throughout. So therefore the series is definitely geometric. So 3.2.2, we are asked to calculate for which value of theta will the series converge. So remember that convergence applies when R lies between -1 and 1. And we found that in our 3.2, R is actually 2 sine of theta. So we're going to substitute this 2 sine of theta into this problem here. So our convergence, which is -1 and 1, our R being equal to 2 sine of theta. So we're going to say 2 sine of theta lies between -1 and 1. Then we divide by 2 both sides. We remain with sine of theta lies between -1/2 and 1/2. Then to find theta, we're going to divide by sine both sides, and we know that it's going to be arc sine, or the inverse rather, of -1/2, and theta here is going to be sine inverse of 1/2. We know very well that the inverse is actually 30 degrees, so it's going to be theta being less than, because this one is negative, it's going to be -30 degrees, and this one here is going to be 30 degrees. So our theta lies between -30 degrees and 30 degrees. Okay, so question 4. We are given the graph of f of x being equals to p to the power of x, and we are told that p must be greater than 0 in the sketch below, and we are given a point which is -3 and 27/8. So 4.1, we are asked to show that p is actually equals to 2/3. So remember that we're given f of x being equals to p to the power of x, and to find the value of p, you must use the point of a, which is -3 and 27/8. So we're going to substitute, knowing very well that this is x value, this is y value. We're going to substitute in this equation here. So where there's f of x, we're going to put 27/8 equals to our p to the power of -3. Then to find the value of p, we simply multiply the power to -1/3, its inverse, then we multiply here -1/3. So p should be equals to 27/8 to the power of -1/3, and you use a calculator, you will find the value to be 2/3. So our p value is definitely 2/3. So 4.2 says that write down the equation of the inverse of f in the form y is equals to. So to write the inverse, we know f of x is equals to p to the power of x, but we calculated p to be equals to 2/3, right? So we're going to substitute that p, so it's going to be 2/3, all, let me write it properly. So it's going to be 2/3 all to the power of x, right? So to find the inverse, we say y is equals to into 2/3 to the power of x, then we swap the x to be y, and y we write x. So meaning where there's y, we put x being equals to 2/3 to the power of y. Then we know very well that we need to write y is equals to. So for us to write y is equals to, we need to solve this problem here using logs, right? So note that this is our base. This is our base, and this is our exponent. So in logs, you should note that log, the base is at the bottom, and it's equals to, so this would be the base, this would be the exponent, which is equals to. So our exponent in this case is y, so it's y equals to our log, our base is 2 over 3, and our value of x, we'll write it here as x. So this would be our equation, which is y equals to log base 2 over 3 x. So this is our inverse of the function. So 4.3, we are asked to sketch the inverse of the function, indicating all the intercepts and one other point. So what you're going to do, having our inverses, y is equals to log of base, which is 2 over 3 x, right? So the x-intercept, so we need to first find the intercept of the function before we draw it. So the x-intercept when y is equals to 0, and our y is equals to 0, log of 2 over 3 here, and x, so meaning that 2 over 3 to the power of 0 is equals to x. So therefore our x is equals to 1. So when y is 0, x is 1. So this is the first point of the x-intercept. So the y-intercept when x is equals to 0, so you have y is equals to log of base 2 over 3 of 0. So here you won't find a solution. So to draw this function here, so let's say we draw it here, the corner, it's gonna look like this. So you're having our x-intercept being 1 and 0, which is somewhere here, 1 and 0. So if you label, this is going to be your y-axis, this is going to be your x-axis. So remember that our function does not touch the y-intercept, hence we couldn't find the solution of the y-intercept. So it's going to look something like this. It's going to approach the y-intercept, but it won't touch it, and here it's going to move away from the y-intercept. So this would be our inverse of the function. So 4.4, we are told that graph of k is obtained by the reflection of f about the y-axis. Determine the equation of k. Write your answer in positive exponent. Remember that the graph of f of x we found to be 2 over 3 all to the power of x. So if they say k is the reflection, of f about the y-axis, so what you're going to do is we're going to say the equation of k is equals to 2 over 3 in place of this exponent of x there, we're just going to write a negative exponent of x, right? Then this means now that our equation of k is going to be the inverse of this. So you're going to write the inverse of this. So instead of writing 2 over 3, you're going to write 3 over 2 all to the power of x. The reason why I did that is I want to make sure that this exponent must be positive as per the question. So this would be our equation of k. 4.5 says that for which values of x will the log of base 3 over 2 of x be less than or equals to 0. What we need to note is since k is equals to 3 over 2 to the power of x, its inverse is log of base 3 over 2 of x. So if you were to draw that inverse, it's going to look something like that. All right. So now we want to identify the values of x such that this log of base 3 over 2 of x is less than or equals to 0. So what are the values of x when this inverse is less than or equals to 0? So these are the solutions of y which are less or equal to 0. We need to note the value of x here. What is the x-intercept at this point? So what you can do is you can find the intercept of this inverse, which is equals to log of base 3 over 2 of x. So if we say x-intercept when y is equals to 0, so if we equate here to be equals to 0, it's going to be 0 is equals to log of base 3 over 2 of x. Then you say 3 over 2 to the power of 0 is equals to x. Therefore x is equals to 1. So meaning that our x-intercept is 1 and 0. So this point here it's 1 and 0. So to go back and answering this question here, saying that what are the values of x when the function is less than or equals to 0? So this is the point where the function is less than or equals to 0. It's this point here. So I'm just going to shade it. So this point here, the function is less than or equals to 0. So to conclude, you can simply say when x is less than or equals to 1, our function is less than or equals to 0. So that is the final solution of x. Okay, so this is question 5. We're given a graph of f of x, which is equals to ax squared plus bx minus 10, and we're also given the graph of g of x, which is m over x plus p plus q. So we're having a parabola and a hyperbola, and we're also given a point of 5 and 0, and we also given d. We are told that those 2 points are actually x-intercepts of f, and e is a turning point of f, which is 3 and k. The vertical asymptotes of g intersects the graph of f at 5 and 0. The horizontal asymptote of g intersects the f graph at the y-intercept. So we have all the information and the diagram below is given. So let's answer the following questions. So the first question says that we should write down the coordinates of the y-intercept of f. Remember that our f graph is given an equation of ax squared plus bx minus 10. So to find the y-intercept when x is equals to 0, we're going to say fx equals to 0 is equals to our a into 0 squared plus our b into 0 minus 10. So the answer here would be minus 10. So the coordinates would be 0 and minus 10. So now we are asked to write down in 5.2. 5.2 says that determine the coordinates of D, the x-intercept of f. So remember that D is one of the x-intercepts. So it's here, the x-intercept of the parabola. So we want to identify the coordinate. We know very well that the y value of D is 0. So we want to find the x value. So to find the x value, we should remember that the parabola is symmetric. So the x value of the turning point here is equals to 3. And we know that the x value here is equals to 5, and we want to identify the x value of d. So we can use that symmetry to find the value of xd. So what we can do is we can find the difference between x of d and the turning point, and which will be equals to the difference here of the turning point and this 5 here. So what I mean by is the x of the turning point has a constant difference with the x intercept, so meaning it divides them. So what we can do is the x, which is this one here, is actually the x of 5 minus the x of the turning point will give you the difference, x of difference. So meaning the 5 minus the x value of the turning point is 3, so we're going to get 2. So we know very well that the difference is actually 2 between x, which is equals to 5, and the turning point, and the turning point and x of d. So to find the difference between the x-intercept and the turning point is equals to 2, right? So what we can do is this, because we want x of d and we know the difference is equals to 2. So what we can do is, to find x of d, we have to say x of d is equals to the turning point, the value of the turning point, which is equals to 3. We're going to minus with the difference of. So what we can do is the x of d is equals to the turning point minus the difference, which is 2. So x of d is equals to the value of the turning point, which is 3, minus the difference, which is 2. So x of d is equals to 1. So therefore d, the coordinates of d will be 1 and 0. So 5.3, we are told to show that the 5.3, we are told to show that the equation of f is equals to minus 2x squared plus 12x minus 10. So for us to show that, we should know our intercepts, and the turning point, we don't really need it to actually find the equation. So the x-intercepts are important, and we know that our d we found to be 1 and 0, which is one of the x-intercepts, and another x-intercept that was given is 5 and 0. So we have these two intercepts, and our f we were initially given as f of x is equals to ax squared plus bx minus 10. So having this information will help us to identify the equation of our parabola. So to find our equation of f, we know very well that f of x is equals to ax squared plus bx minus 10, meaning that our y-intercept is actually y is equals to minus 10. So in coordinate form it's 0 and minus 10. and we know our x-intercepts that we found to be 1 and 0, and the given one is 5 and 0. So you're going to use the equation of f of x being equals to a into x minus x1 x minus x2. Our f of x, we're going to write this minus 10, so it's going to be minus 10, and then where we see x, we're going to put 0. So it's going to be a into 0 minus x1, 0 minus x2. So where there's x1 and x2, we're going to put our intercepts, which is 1 and 5. So it's minus 10 equals to a into 0 minus, we're going to put the positive 1, so it's going to be 1, and 0 minus, we're going to put positive 5. So we have minus 10 is equals to a into, so 0 minus 1 is going to be minus 1, 0 minus 5 is going to be minus 5. Then now we have minus 10 is equals to, so minus 1 times minus 5 is going to give you 5a, then divide by 5, our a value is equals to minus 2. So this is our a value, so we're going to substitute the a value here. So meaning that we're going to have our f of x being equals to our a value, which is minus 2, into x minus our intercept, which is 1, and x minus our intercept, which is 5. So this is the equation, so you're going to continue to solve it. So you're going to say f of x is equals to minus 2 into x minus 1, x minus 5. So you're going to use the FOIL method to find the solution for this portion, and then later multiply with this 2 here. So we have f of x, it's equals to minus 2 into, so FOIL method is going to be x multiplied by x is going to be x squared, x multiplied by minus 5 is going to be minus 5x, and then minus 1 multiplied by x is going to be minus x, and then minus 1 multiplied by minus 5 is going to be positive 5. Then equals to minus 2 into x squared, we add the like term, so it's going to be minus 6 plus 5. And then our f of x, we're going to be equals to, so this minus 2 will multiply everything that is inside, so it's going to be x here. So it's going to multiply everything that is inside, so it's going to be minus 2x squared plus 12x minus 10. Right, so our f of x for this graph is minus 2x squared plus 12x minus 10. So this is our equation of f of x. So now 5.4, we are asked to calculate the value of k, the y coordinate of the turning point. So if you can see here, it is the y value of the turning point. We already have the x value being x equals to 3. So we just want the y value of the turning point. So to find our y value of the turning point, remember that our f of x that we calculated in initial equation. So to find our y value of the turning point, remember that the f of x, which we calculated initially, is minus 2x squared plus 12x minus 10. And we already know the x value of the turning point, which is equals to 3. We're simply going to substitute that x equals to 3 into our f of x to find the y value of the turning point. So if you punch your calculator, you will find that the y value of the turning point is equals to 8. So therefore our k value is equals to 8. We are going to do 5.5. Says that determine the equation of g. So the equation of g, it is of the form g of x is equals to m over x plus p plus q. So this is your hyperbola. So we're going to find the equation of this hyperbola. So let's have a look at the information that we have for this hyperbola here. What we need to note is that this hyperbola intersects the the graph of f at the turning point and at this point here. So we already know that the point of this hyperbola is 3 and 8, since we found that the k value is equals to 8 in the initial equation, in the initial question, sorry. So we have the point for the hyperbola, and what we need to note is that where it intersects the, and another thing that you need to note is that this dotted line here that we see moving, this dotted line here, we know that it is actually a y-intercept for the graph of f, and in the initial question we found that that y-intercept is actually equals to -10. So but for the parabola, since you can see it does not touch this line here, so it means now this is actually the horizontal asymptote of the hyperbola. So we're having the horizontal asymptote, and we're also having a point to actually find the equation of this hyperbola here. And also what you need to note is that this dotted line here that is moving downwards like that, it is actually the y-intercept of the graph of f, but it is also the vertical asymptote of the hyperbola. So we're having the vertical asymptote, which is equals to 5. We're having the horizontal asymptote, which is equals to -10, and you also have this point here. So having these three we'll be able to solve or find the equation of the hyperbola. So we're having the horizontal asymptote. So to solve the problem, we have the horizontal asymptote. So to solve the problem, we're having a point of 3 and 8 for the hyperbola, and we have the horizontal asymptote of -10, and we have the vertical asymptote of 5. And we know that the g of x is equals to m over x plus p plus q, right? And we're going to substitute the asymptote, so it's going to be g of x is equals to m over x. Because the vertical asymptote is positive, if you take it to the other side, it's going to be -5, and the horizontal asymptote is -10, so we're going to write -10. So for us to complete the equation of this hyperbola, we need to find the value of m. So we're going to use the point of 3 and 8 to find the value of m. So we're going to substitute this point, and we're going to say 8 is equals to m over 3 minus 5 minus 10. So we're going to have 8 is equals to m over 3 minus 5 is minus 2 minus 10. Transpose the minus 10 to the other side. We have 8 plus 10 is equals to m over minus 2. 8 plus 10 is 18, is equals to m over minus 2. Then we cross multiply. So our m is equals to minus 2 times 18, right? So our m is equals to minus 36. So therefore, our equation of g of x is equals to our m, which is minus 36 over x minus 5 minus 10. So this is the equation of g of x. 5.6 says that calculate the y-intercept of g. So we calculated the equation of g in the previous question, so now we'll find the y-intercept. So remember that our graph of g of x is equals to minus 36 over x minus 5 minus 10. So to find the y-intercept when x is equals to 0, so it's going to be g of x equals to 0 is equals to minus 36 over 0 minus 5 minus 10. So you're going to punch your calculator and you will find minus 14 over 5, which approximate to minus 2.8. So to write in coordinate form, we have 0 and minus 2.8 as our y-intercept. 5.7. If h is the decreasing axis of symmetry of G, Determine the equation of h in the form of y is equals to mx plus c. So when they say it's a decreasing axis of symmetry, so in the hyperbola we have two axes of symmetry. We have a positive axis of symmetry which has a gradient of positive 1. We have a negative axis of symmetry which is a gradient of negative 1. So for us to find the equation of our axis of symmetry, whether positive or negative, we need to use y is equals to mx plus c, knowing the value of m. So if it's positive axis of symmetry, it's going to be x plus c. If it's a negative axis of symmetry, it's going to be y is equals to minus x plus c. So to find the value of c, we always have to substitute our coordinate of the asymptote. So we can have the horizontal asymptote coordinate and the vertical asymptote coordinate. So we'll substitute these coordinates to this coordinate rather to find the value of c, so that we can complete in finding the equation of our axis of symmetry. So in this question we are asked to find the decreasing axis of symmetry of g, so meaning that we're going to focus on m is equals to minus 1. So to complete in finding our axis of symmetry, we know m is equals to minus 1, and our coordinate of asymptotes, we know it's 5 and minus 10, right? And another thing that we'll need is our y is equals to mx plus c, knowing very well that our m is equals to minus 1, so it's minus x plus c, and then we substitute our point, which is our horizontal and vertical asymptotes. So this is the vertical asymptote, this is horizontal asymptote, so of 5 and minus 10, and then minus 10 is equals to minus into 5 plus c. So transpose the minus 5 to the other side. We have minus 10 plus 5 is equals to c. So therefore our c is equals to minus 5. So to complete our equation, we want to say y is equals to minus x minus 5. So this is your equation that is decreasing, the decreasing axis of symmetry of the hyperbola. So now 5.8, we are asked to calculate the x-intercept of g. So to find the x-intercept of g, we know that g of x is equals to minus 36 over x minus 5 minus 10. So x-intercept when y is equals to 0, so it's going to be 0 is equals to minus 36 over x minus 5 minus 10. We transpose the 10 to the other side. We have 10 is equals to minus 36 over x minus 5, and then we cross multiply. I'm going to have 10 multiplied by x minus 5 equals to minus 36, and then we divide by 10 both sides. We have x minus 5 is equals to minus 36 over 10. And then we're going to transpose the 5 to the other side. We have x being equals to minus 36 over 10 plus 5. And the final answer is going to be 7 over 5. So this is the x-intercept of the function here. So it's going to be 7 over 5 and 0. So 5.9, we are asked for which values of x will the function of f multiplied by the function of g give you solution of y which is less than 0. So less than 0 meaning the solutions of y should be negative, right? Cool. So let's go to our graph here and see this problem here. So what you need to note is first here the point of the y-intercept, we know now that it is 7 over 5 and 0, and here and then we need to note that here the y-intercept is actually 0 and minus 10, right? So we want to find the solutions of x when the f of x multiplied by the g of x will give you less than or equals to 0. So to really identify that case is you have to look, okay, fine, we're having the y values of the f of x. So let's say we look at this portion here, the y values, the sign of the y values of this intercept, the y values are negative here, negative throughout up until they reach this point. They're all negative, and the y values of the hyperbola are also negative. So if you were to multiply a negative and a negative, will give you positive. So that's what we are not looking for. But if we have a look here, but if we have a look here at this point here, so we know at D has coordinate 1 and 0, right? And if we have a look at just this portion here, this small portion here, so let me erase this one here. So if you have a look at the boundary that I've just set, between this boundary, which is the blue line, you need to note that the y value of the hyperbola, it's positive here. Going down, it's positive, going down up until this point here, right? And the y value of the hyperbola, it's positive here, positive here, positive here, positive here, positive here, positive here, up until x is equals to 7 over 5, and then it starts to be negative, 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 right? So let's look, because we want to multiply f with g and give us a solution that is less than or equals to 0. So basically a solution that is negative. So if you take a look, so what we can do here is this: we can multiply these positive values here, these positive values. If you multiply them with these negative values, then we'll definitely get a solution that is less than 0. So if you multiply a positive and a negative, you definitely get a negative. So which means we need to focus on that and neglect this portion here, up until this point where we reach x is equals to 7 over 5. So we're going to neglect this point here. We neglect it. We look at this part and this part here. So where does that happen? So if I erase the part that we are neglecting and we focus where now x is actually equals to 7 over 5. So meaning I need to create a boundary here, a boundary from this point going downwards. So this boundary will have another boundary. So let me just erase everything here so that it becomes neat for you to see. So now at this point we know x is equal to 7 over 5. So I'm going to create a boundary going up like that, and I'm going to create another boundary at d, which is equals to 1 and 0. I'm going to do like this. So as I've indicated, we know that for f the y values here are positive, but now for g the y values here are negative, which is what we are looking for. We want to find a positive value, multiply it with a negative value of y to give us a negative value of y. So this is where the solution, the situation happens, where we have positive values multiplied with negative values will give us a solution of negative value. So what are the x values when this case happens? So you're going to use the d and this intercept of 7 over 5. So we're going to say when x lies between 7 over 5 and 1, then you're having solutions of y which are less than or equals to 0. So this is the solution for your question here. So therefore, since we're looking at the graph of f and g, and as I've indicated, we're going to look at the point between d, which is 1 and 0, and the other intercept, which is 7/5 and 0. So look at the between those 2 points. You can simply conclude, since I've explained that your x lies between 7/5 and 1. So this would be your solution of x. So 5.10 says that for which values of t will g of x for which values of t will g of x plus t equals to 0 have one negative root. So what you're going to do is this. You have g of x plus t is equals to 0. So you want to identify the values of t, right? But we need to note that, okay, fine, if you transpose this t to the other side, you have g of t being equals to minus t. So whatever value of t you have, it will be negative in terms of t, right? So remember that g of t, it's actually a y-intercept, right? It's actually a y-intercept. And if you remember, you recall the y-intercept of previous questions, we had a y-intercept which is equals to minus 2.8, and another y-intercept which is equals to minus 10, right? So the minus 10 was actually the horizontal asymptote, right? So we're having these two y values here, so which are actually equals to minus t. So if we say g of t is actually equals to minus 2.8, which is equals to minus t, therefore t will be equals to 2.8, right? Or if you say minus 10 is equals to minus t, therefore t will be equals to 10. So basically our t, the element of t lies between your 2.8 and your 10. So these are actually the values of t, 2.8 and 10. Okay, question 6. Kevin inherited 800,000 and invested full amount at a bank. The bank paid him an interest rate of 8% per annum compounded monthly. 6.1. If Kevin withdrew 120,000 rands from the account 1 year after making the initial investment, how much was in the account 2 years after making the initial payment? What we need to know is that Kevin inherited 800,000. Okay, so the first step we're going to do here, we're going to draw our timeline. So at t0, which we know the event that happened there is 800,000 was inherited by Kevin, and at t1 he withdrew an amount of 120,000 rand. So I want to know how much is in the account in 2 years time. So from t0 to t1, a is equals to p into 1 plus I to the power n. The initial investment is 800,000 into 1 plus interest rate of 0.08 divided by 12 compounded monthly to the power 12 times 1, because t0 to t1. Then the amount you're going to get there is going to be 800,600 and so the amount we're going to get is the following: 866,399.6. Remember that we're having a withdrawal of 200,000 at T1, so we're going to withdraw remember that we're having a withdrawal of 120,000 rand at T1, so we're going to withdraw 120,000 rand into the account. So the amount at T1 is going to be 746,399.6. so this is the amount at T1, but we are looking for an amount at T2. So what we're going to do is going to say T1 to T2. A is equals to P into 1 plus I to the power n, and P will be the amount which we found initially, which is 746,399.6 into 1 plus interest rate of 0.08 over 12 to the power 12 times 1, because from T1 to T2 is 1. Then the final answer that we're going to get is the amount of money is going to be 808,350.4 at T2. 6.2 says that 2 years after making the initial investment, Kevin decided to enroll at a university. He decided to use the money from his investment to pay for his studies. 6.2.1 convert the nominal interest rate from monthly to half yearly. Convert the interest rate. What you're going to do, you're going to write the formula 1 plus I effective is equals to 1 plus I nominal over m to the power m. So what you need to note is we're going to first identify the effective combined with this 1 there, and then we convert the nominal interest rate into half yearly. So what we're going to do is we're going to say 1 plus I EFF for effective into 1 plus the nominal interest rate was given as 0.08 divided by 12, which is monthly, to the power 12. So if you find the decimal of this here is going to be 1.082995. So let's say there's 9 there, 50681. So let's consider this answer here, 1 plus IEFF, right? So what we're going to do is we're going to say, okay, fine, so this portion here is equals to this, right? So to find the half yearly, we're going to say but 1 plus IFF is equals to 1 plus is equals to 1 plus I half over m to the power m. So this portion here is equals to this portion there, or the number there. So it's going to be 1 plus I half over m to the power m is equals to 1.08299950,681. So to find the value of m, knowing very well that half means 2, So where there's m, we're going to put 2. So it's going to be 1 plus I half over 2 to the power of 2 because it's half yearly. Then 1.08299950681. So to find I of half, we're going to put the square roots on both sides, and it's going to be 1 plus I half over 2 equals to 1.0406726223. Then you transpose the 1 to the other side. We're going to get I half is equals to 0.0406726223. Then we multiply by 2 both sides. Our I half is equals to 0.0813. So let me end at 13, and then because we are looking for a percentage, I half is equals to 8.13%. So this is your final answer of the problem here. So 6.2.2, Kevin will need to withdraw 95,000 Rand every 6 months to pay off his studies. The first withdrawal is at the beginning of the first semester. Calculate how many complete semesters this investment can finance his studies. So we know that there's an investment that Kevin made for his studies that he paid, which was initially at 80350.4. So this was it's actually 808,350.4, the initial amount that he placed. So with this initial investment, we are told that he made a withdrawal of 95,000. So 95,000 Rand was withdrawn in the account. So we want to identify the number of payments that Kevin made into this investment for his studies. So what basically means that since we have the total payment of 800,000, 8,350, and an immediate withdrawal. So what we're going to do is we're going to use the present value formula of PV is equals to X into 1 minus P. So we're going to use the present value formula, which is equals to X into 1 minus into 1 plus I to the power of minus N divided by I. Why are we using the present value? It is because there's a lump sum amount that has been invested, and there's certain portions of money that is in a form of income that is received at a certain period of time according to this problem here. So what we're going to do is we know very well that PV is equals to the 808,350.4 that was invested for his studies. Kevin invested this amount of money for his studies, but we need to remember that he just made a withdrawal of 95,000 rand. So it changes the PV value, right? So what you're going to do is this. We're going to subtract so now PV is equals to 713,350.4. So this is now the new present value of the problem. So we're gonna say PV is equals to x into 1 minus into 1 plus I to the power of minus n over I. So now we have 713,350.4 is equals to our withdrawal of 95,000 rand into 1 minus into 1 plus our interest rate of the problem, which is 8.13%, so which is going to be 0.0813 over it's compounded half yearly, so it's to the power of minus n divided by 0.0813 over 2. So you don't have to find the final answer now, just multiply, cross multiply. So we're going to have 713,350.4 times 0.0813 over 2 is equals to 95000 into 1 minus into 1 plus 0.0813 over 2 to the power of minus n. So we're going to divide by 95,000, divide by 95,000. So we will have 713,350.4 times 0.0813 over 2 divide by 95,000 is equals to 1 minus into 1 plus 0.0813 over 2 to the power of minus n. Transpose the 1 to the other side, you're going to have 713,350.4 times 0.0813 over 2 divided by 95,000 minus 1 is equals to minus into 1 plus 0.0813 over 2 to the power of minus n. So the answer that we're going to get here is going to be minus 0.6947611183, which is equals to minus into 1 plus 0.0813 over 2 to the power of minus n. So the minus will divide out. We will remain with 0.6947611183 equals to 1 plus 0.0813 over 2 to the power of minus n. Then we're going to use our log to find the value of n. So it's going to be minus n is equals to log of our base, which is 1 plus 0.0813 over 2, and multiply by our value of 0. So it's not necessarily multiplying, but it's 0.6947611183. So if you remember your logs, you know it's log of base multiplied by this value here, or it's actually inside the bracket form. So our solution of n is equals to minus 9.139979. Let me leave it here. Then you divide by -1, divide by -1. So n is equals to 9.14. Okay, question 7. We have 7.1 here. Given f of x, which is equals to 3x squared plus 11, we are asked to find the derivative using first principles. So f of x is equals to 3x squared plus 11. So the formula of first principles is given as f of x plus h minus f of x divided by h. So remember that it is actually a limit when h approaches 0. So let's first find f of x plus h. So which means we're going to substitute in this function here. So it's going to be 3 into x plus h all squared plus 11. So f prime x is equals to the limit when h approaches 0 of 3 into x plus h squared plus 11 minus our f of x, which is 3x squared plus 11 divided by h. So we're going to deal with what's inside. So it's going to be 3 into our x plus h multiplying with our x plus h plus 11 minus 3x squared plus 11 all over h. So that is the limit when h approaches 0. So limit when h approaches 0, so we have 3 into, so we find the product using FOIL method. It's going to be x squared plus 2hx plus h squared, right? So meaning that we're going to have x times x, which is x squared, x times h, which is xh, plus x times h, which is xh. Then we have to add h squared, which is found by multiplying h times h, which is what we found here. Then we're going to add 11 minus, so we put the solid brackets here, then minus into 3x squared plus 11 divided by h. So the limit when h approaches 0, so the 3 will multiply everything that it finds inside here. So it's going to be 3x squared plus 6hx plus 3h squared plus 11 minus 3x squared, because the negative will multiply everything that is inside here, minus 11, because this is positive 11 divided by h. So what's going to happen is this 3x squared will subtract this one, this 11 goes away with this one. We are left with the limit when h approaches 0 of 6hx plus 3h squared divided by h. So limit when h approaches 0 is equals to, so we're going to factorize the h, so we'll be left with 6x plus 3h over h. Therefore the h divides out. We are left with the limit when h approaches 0 is 6x plus 3h. So we're going to substitute this h as 0, so it's going to be 6x plus 3 into 0. We'll be left with 6x. So this is the final answer of your derivative using first principle. Having y is equals to 2x to the power of 4 minus pi root of x plus 8 over root of x. So before we derive, let's first break this problem. So it's going to be broken like this: minus pi root of x over root of x plus 8 over root of x. So y is equals to, please note that root of x is the same as saying x to the power of 1 over 2. So meaning 2x to the power of 4 over x to the power of 1 over 2 minus this portion here, it's root of x and root of x divide out. Then we are left with minus pi plus 8 over x to the power of 1 over 2. So let's first deal with this problem before we derive. So it's y is equals to, we're going to take this x to the power of half to the top, so it's going to be 2x to the power of 4 multiplied by x to the power of minus 1 over 2 minus pi plus 8x to the power of minus 1 over 2, because we take this to the top. So it's going to be y is equals to 2x to the power of, so 4 minus 1 over 2 is going to give you 4 minus 1 over 2 is going to give you so 4 minus 1 over 2 is going to give you 7 over 2 minus pi plus 8x to the power of minus 1 over 2. Then from here onwards, we're going to derive. So d of y with respect to x is equal to, so we're going to drop the 7 over 2 multiplied by 2, x to the power of 7 over 2 minus 1, and the derivative of pi is 0, so it's plus 0 plus, and then we drop the minus 1 over 2 times 8x to the power of minus 1 over 2 minus 1. Therefore, d of y over d of x, this 2 goes away with 7x to the power of 5 over 2 minus 8 divided by 2 is going to be minus 4x to the power of minus 3 over 2. Then this is our answer, but we can write this exponent in positive form. So meaning d of y over d of x is equals to 7x to the power of 5 over 2 minus 4 over x to the power of 3 over 2. So if you like, you can leave your answer to this format, or you can simply continue and write it properly. So it's 7 root of x to the power of 5 minus 4 over root of x to the power of 3. So this is the final answer of question 8. The sketch below represents the curve of f of x, which is a cubic function, and it has a turning point at d, which is equals to minus 2 and 32. So that's the first turning point, and the gradient of the tangent at x equals to 3 is 15. So 8.1, we are asked to show that the value of a is equals to 1, b is equals to minus 12, and c is equals to 16. So we're going to use the given information. We're going to use the turning point, we're going to use the gradient of the tangent to find the value of a, b, and c. So the first thing we're going to do is we're going to write our f of x, which is equals to ax cubed plus bx plus c. And because we are given the turning point, which is minus 2 and 32, right? It is the point of d, right? So we have to derive this cubic function. So it's going to be 3ax squared plus b. Then we're going to substitute this turning point here. Where there's x, we're going to put minus 2. Where there's y, we're going to put 32. So then from here we have the derivative, so we're going to equate the derivative to 0. So 0 is equals to 3ax squared plus b, and then we use the turning point, which is minus 2 and 32. So we're going to substitute the x value of the turning point, which is minus 2. So 0 is equals to 3a into minus 2 all squared plus b. So it's going to be equals to 0 is equals to 3a multiplied by 4 plus b. So it's going to be 3 is equals to 0 is equals to 12a plus b. So this is going to be your equation 1 for this problem here. So therefore we go back to our first derivative, which is equals to 3a x squared plus b, right? And we are told that the x value of the tangent is equals to 3, right? And we are told the gradient of the tangent, which is equals to 15. So we're going to substitute that. So instead of writing f prime x, you're going to write 15, which is the gradient. 3a, where there's x, we're going to put the value of the tangent plus b. So it's going to be 15 is equals to 3 squared is 9. So it's going to be 3a multiplied by 9 plus b, right? So it's going to be 15 is equals to 3 times 9 is 27. So it's going to be 27a plus b. So this would be your equation 2. So now you have equation 1 and equation 2, and you want to find the value of a and b. So you can use simultaneous to find the solutions here. So your equation 1 is equals to 0 is equals to 2. So your first equation, which is 0, is equals to 12a plus b. And your second equation, which is equals to 15 equals to 27 a plus b. So this is equation 2. To write it properly, so you can write and equate to b both equations, this and this one. So starting with equation 1, we can say b is equals to 12a, and say maybe it's equation 3. And then this one here, we can say b is equals to 15 minus 27a. We can say it's equation 4. So if we equate equation 3 with equation 4, we're gonna get 12a is equals to 15 minus 27a. Then we transpose the 27a to the other side. We have 12a plus 27a is equals to 15. Then now so to equate our equations, starting with this equation 1, we're going to say b is equals to minus 12a. We can say this is equation 3. And this one here, we can say b is equals to 15 minus 27a, which is equation 4. So we can simply say equation 3 is equals to equation 4. Equation 3 equals to equation 4. Equation 3, which is equals to minus 12a, equals to equation 4, which is equals to 15 minus 27a. Transpose 27a to the other side, we have minus 12a plus 27a equals to 15. Then minus 12a plus 27 is going to give you 15a, which is equals to 15. So divide by 15 both sides. We're going to get a being equals to 1. Remember that we said b is equals to minus 12a. So you're going to substitute the 1. So it's minus 12 into 1. So b is equals to minus 12. Then we need to find our value of c. So to find our value of c, we now have f of x equals to, remember our f of x equals to ax cubed plus bx plus c. So we already found the value of a and b. F of x is equals to, our a is 1, so it's x cubed. Our b is minus 12x plus c. So what we're going to do is we're going to substitute our point, our turning point of minus 2 and 32. So it's going to be 32 is equals to minus 2 cubed minus 12 minus 2 plus c. All right, so 32 is equals to 8, so it's going to be negative 8, and then 12 multiplied by 2 is going to be positive 24 plus c. Then you're going to transpose these two numbers to the other side. You're going to have 32 plus 8 minus 24 is equals to c. So therefore our c value is going to be equals to 16. 8.2.1, we must calculate the x coordinate of the point of inflection. So to find the point of inflection, we first need to define our f, which is x cubed minus 12x plus 16, right? So the point of inflection is the third derivative. So the first derivative of this problem here is going to be 3x squared minus 12. The second derivative is equals to 6x. So this defines the point of inflection. So to find the x coordinate of the point of inflection, you equate the second derivative to 0. So 0 is equals to 6x, then you divide by 6 both sides, x is equals to 0. So this is the x value of the point of inflection. 8.2.2, we are asked to determine the values of x for which the f is concave down. So if you take a look at this graph here, this portion is concave up. This portion here is concave down. So we're going to use the point of inflection to actually predict the concavity of this graph. So we know very well that the x value of the point of inflection is equal to 0, meaning it's somewhere here, right? So since the x value of the point of inflection is equals to 0, to define the concavity, concave down, it's x less than 0. So any value that is less than 0 will define the concavity of the function to be down. So it's going to be concave down. As you can see in the diagram here, concave down is just below x less than 0. Anything below x equals, anything of x less than 0 will mean that it has a graph or the concavity facing downwards. 8.3 says that write down the coordinates of d prime, the image of d reflected about the x-axis. So this is the x-axis. So if you reflect anything about the x-axis, which means now if you reflect this d, which is this point here, about the x-axis, means now the graph will look something like this, right? It's gonna be something like this. So where there was d there at that point, it's going to come here, which we call d prime. So the x value, because it's minus 2 here, it won't change, so it's still going to be minus 2. The only thing that will change is the y value, because it's at this point, which is 32. At this point now it's going to be minus 32, so meaning that d prime is going to be minus 32, like that. So that is the new image of d. Then 8.4 says that is f a function? Give a reason for your answer. So for us to prove that the graph of f is a function, we need to test it using the vertical line test. So if you were to test the vertical line test, x is equals to y in each and every point. X is equals to y. So if x is equals to y, then which means the graph passes through, like it passes the vertical line test. So what we can conclude is say yes, f is a function. Reason is f pass the vertical line test. Question 9. The sketch below shows the graph of y is equals to f prime of x. So is the derivative of a cubic function gives you a parabola. The turning point of f prime is 1 and 2, and the y-intercept is 0 and 3. So we are given the diagram below. So 9.1 says that for which values of x is f increasing. So they're talking of a cubic function, not necessarily this parabola. So what we need to note is, since this parabola is a smiley face, it means that our cubic function increases, decreases, and increases, right? So we want to identify the values of x when our cubic function increases. So how are we going to determine that? We're having the turning point of this function here at 1 and 2. So and we also have the intercept. So this is the intercept. So the intercept of our parabola is actually the turning point of our cubic function, but it's I'm only talking of the x value of this graph here, not necessarily the y value. So for this answer for 9.1, you can simply say that the graph of f increases. X is the element of real numbers. So meaning that if you look at this side here, the graph of a cubic function is increasing from a negative infinity up until this point of the turning point. And also from here, the graph of a cubic function is increasing from this turning point all the way up to a positive infinity. Hence, I'm saying the graph of f increases from negative infinity to positive infinity, excluding this middle point between the turning point of this part and the turning point of this part. So hence you can simply write this as your solution for 9.1. So your answer can simply be x is the element of real numbers, or you can simply write from negative infinity to positive infinity. 9.2. What is the gradient of the tangent to f at x is equals to 1? So what we need to note is that the derivative of a cubic function gives you a parabola, which is going to, so the derivative of a cubic function gives us a parabola, which helps us to identify the gradient of a tangent. So for us to identify the tangent at x is equals to 1, we have the turning point and a point for the parabola. So we can simply find the equation of this parabola here. So what we can do is this: we can simply write f prime of x is equals to a into x plus minus p squared plus minus q. So our turning point is given as 1 and 2 from the diagram, and we have a point which is at 0 and 3. We also know that the tangent, the x value of the tangent is equals to 1. So to write this equation, we can simply say f prime of x is equals to a into x. So the x value of the turning point is 1, as I've indicated, so we're going to write minus 1 there squared, and the y value of the turning point is 2, so we're going to say plus 2. So we're going to substitute the point or the intercept of 0 and 3, and we're going to write 3 here is equals to a into 0 minus 1 squared plus 2. Then we're going to find the value of a, so that we'll be able to identify the equation of the parabola, then be able to find the gradient of the tangent. So it's going to be 3 is equals to 0 minus 1 is going to be a into minus 1 squared plus 2, which is 3 is equals to a plus 2. Transpose the 2 to the other side, you have a equals to 3 minus 2, which is equals to 1. So your a is equals to 1. Then your f prime of x is equals to 1 into x minus 1 squared plus 2. But we know that the x value of the turning point is equals to 1. So we can substitute that value here. So we're going to have f prime of x of the tangent is equals to 1, which is equals to 1 into 1 minus 1 squared plus 2. So 1 minus 1 will give you 0. So meaning that you have 0 plus 2, which is equals to 2. So this is the gradient of your tangent. 9.3. Sketch the graph of f if it is given that f of 0 is equals to minus 2 and f of 1 over 2 is equals to 0. Label all the x and y intercepts, stationary points, and points of inflection, if any. So we are told that f of we are told that f of 0 is equals to minus 2. So this is the so this is the y-intercept, and then we're also told that f of 1 over 2 is equals to 0. So this is the x-intercept when y is equals to 0, right? So to draw our function, we're going to indicate the intercepts. Start with this one, which is 1 over 2 and 0, and then this one here, which is 0 and minus 2. So these are intercepts, and we know the turning point. Our turning point is minus 1 and 2. Oh, and our turning point, we know the y value is not defined for this graph, but we know that the x value of the turning point is equals to 1. So if this is half, then 1 can possibly be here. So the x value of the turning point is here, which is equals to 1. So let's say, for an example, we assume that the turning point is here, because we don't know the y value of the turning point. We don't have the original equation of f, hence we cannot define the y value of the turning point. So just going to indicate and say this is my turning point, and then if I were to draw the graph, the turning point, so meaning that the graph will face that direction, and then it will change and go down here. Let me do it nicely. So it's gonna go down there and look something like this. So this would be the turning point of 1 and y, because we don't know the y value of the turning point. So this would be my graph of f. Okay, question 10. A school bus is traveling uphill on a mountainous gravel. As you can see, this school bus is traveling uphill on a mountainous gravel. Due to the bad state of the road, the diesel tank cracked and diesel started leaking quickly. The bus is at a point of A. So as you can see, this is point A, 2 kilometers from the top of the hill, point B. So from this point A up to point B, the distance is 2 kilometers. At the time the tank cracked. So the position rather of the bus with respect to A is given as follows. So this is the position of the bus with respect to A, with respect to this point here, point A, where T is measured in minutes, S is measured in kilometers. 10.1. How far is the bus from point A after just 1 minute? So we know the distance at A of the bus is equals to t minus t squared over 6, right? So we are told that after 1 minute, so we want to know the distance of the bus after 1 minute. So t is equals to 1 minute. So what is the distance? So we're going to substitute that one. So it's going to be s of t is equals to 1 minus 1 all squared over 6, which is equals to 1 minus 1 over 6, giving us 5 over 6 kilometers. So that is the distance, which approximates to 0.833 kilometers. (10.2) If the bus reaches the point of the hill at point B, if it reaches this point here, the bus driver will be able to roll free will down the hill to the gauge. So if it happens that this bus reaches this point here, so then it will allow the bus to just roll towards the garage, since we were speaking that the bus is leaking diesel, right? So will he reach the top of the hill? So that's the question. We want to know if he'll be able to reach the top of the hill. If he reaches the top of the hill, then he'll be able to arrive at the garage, because the car will just roll without the use of the diesel, right? So we want to know that will the driver be able to reach point B. So the first thing we're going to do here is we know the equation that defines the position of the bus at A, right? Which is equals to t minus t squared over 6. So this defines the position of the bus at A. So we want to know if it will arrive at B. So how we do that, we need to first find the derivative of this position here, which is going to be 1 minus, we drop the 2 over 6 t2 minus 1. So s derivative is equals to 1 minus, so we divide this out, it's going to be t over 3, right? So now with this here, we know very well that since we derived, we're going to equate s of t being equals to 0. So what we're going to do here, we're going to find time. So 1 minus t over 3, transpose the t over 3 to the other side. So it's t over 3 is equals to 1. Cross multiply, t is equals to 3 minutes. So it's going to take 3 minutes for the bus to move from point A. If you remember, point A is here. We don't know if it's going to arrive at point B, but we know that it's going to move for 3 minutes. So we want to identify now the distance that it's going to move with that 3 minutes. So you're going to substitute the 3 minutes to the original equation. So our t is equals to 3 minutes. But the equation that determines the position of the bus at A is this one, right? So you're going to substitute this 3 minutes. T is equals to 3 to identify the distance that this bus is going to travel. So we're going to say 3 minus into 3 all squared over 6, right? And the distance that I'm getting is 3 over 2 kilometers, which is approximating to 1.5 kilometers. So, but you need to remember that from point A to point B, the distance that was initially given is 2 kilometers, which means it takes 2 kilometers to move from point A to point B. But this bus is going to be able to travel 1.5 kilometers. So this basically tells us that the bus won't be able to reach point B as the diesel leaks too much. So therefore, this means that the bus will only travel 1.5 kilometers and will not be able to reach point B, right? So now we know that the bus won't be able to reach point B. If it doesn't reach point B, which means it won't be able to reach the diesel to fill up the tank. .3. At what speed would the bus be traveling at exactly 1 minute after the diesel tank cracked and started leaking? So we want to know the speed at which this bus is going to travel at, if we know the time is 1 minute. So what we're going to do here is this. We know the distance, the equation that determines the distance of the position of the bus at A is equal to this equation, and we want to identify the speed at which this bus is going to travel at. So this S of t is the distance, right? Or you can call it the displacement. So to find the speed, you have to derive. So when you derive the distance, you get the speed or the velocity. When you derive the velocity, you get acceleration. So we're going to derive this distance here. We're going to have 1 minus 2 over 6 t, which would be 1 minus t over 3. So this equation here defines the velocity of the bus. So we need to substitute t, which we're given t as 1 minute. So s prime of t, which is the same as velocity of t, is equals to 1 minus, instead of writing t, you're going to write 1 minute divided by 3. Therefore our velocity is 2 over 3 kilometers per minute. So if you write it in decimal form, it's going to be 0.67 kilometers per minute. So this is going to be the velocity at which this bus travels immediately after 1 minute. So 10.4, calculate the acceleration of the bus at which it is traveling uphill after the diesel has cracked. So we still know that the diesel cracked immediately after 1 minute, right? But in this case, we might not need to know time. So as I said earlier on that if this is a distance of t and you find the first derivative of t, then you find the second derivative of t. So this is the displacement, right? Displacement, or someone can call it distance. So the derivative of distance gives you velocity. The derivative of velocity gives you acceleration. So to find our acceleration, we're going to say s of t, which is equal to t minus t squared over 6. The derivative, which gives us the velocity, is 1 minus 2t over 6, which is 1 minus t over 3. And the second derivative of t is equals to 0 minus 1 over 3, which is minus 1 over 3, right? So this is the acceleration. This is the acceleration, s double derivative, which is acceleration, is equals to minus 1 over 3 kilometers per minute squared. So this is the acceleration of the bus. Okay, so this is question 11. So this is question 11. It reads as follows: a certain school wants to paint their computer room. A survey was conducted among the boys and girls who take CAT, which is computer subject, and IT. So both CAT and IT as a subject, to establish their preference of color. So the results are shown in the table below. So we're having boys and girls who have their own preferences on how the computer room should look like. So the boys want the room to be blue are 19, and those that want the room to be green are 31. So the total number of boys who want the room to be blue and or green, because this is just a combination of both colors, it's going to give you 50. So the number of girls that prefer the room to be blue are 41. Those that prefer it to be green are 35, sorry. So the total number is actually 76 girls who have decided on the color of the room. So then here at the end, it's the total number of boys and girls that prefer the room to be blue, and this is the total number of boys and girls that prefer it to be green. This is just the total number of both boys and girls, 126. Fine. So 11.1 says that if a learner from this group is selected at random, what is the probability that he or she will choose green? So we need to include both boys and girls. So here we're just gonna look at the color green because we are including both boys and girls, right? So for us to solve this problem here, we're going to say the probability of green, looking at the diagram, probability of green. What is the probability of green? This is green, right? This is green. So if we look at the green, including boys and girls, we can say the top part is 66. So this is the total number of green, both boys and girls, who want this room to actually be green. So this is the total number of students, both boys and girls, divide by the total number of boys and girls, blue or green color, the entire room of students. It's 126. So this would be the probability, which is equal to 66 over 126. Then going to 11.2, are the events being a boy and choosing blue as preferred color independent? So let's do this. So now we want to know, are the events being a boy and choosing blue as a preferred color independent? So we're going to look at a boy, the probability of a boy, and the probability of the color blue. And we want to determine whether the probability of these is actually independent, right? So what you're going to do is this. Let's first find the probability of a boy and blue from the diagram, from the contingency table, right? So where's the probability of a boy? This is the boys, so it is actually 50. So there it is 50, right? And probability of color, so the color is actually, as you can see there, it's okay, so let's look at the probability of being a boy and with the color blue, right? So the probability of being a boy, so this is the boy with color blue. So this is the probability of being a boy and having color blue, so which means it's 19, right? So we say probability of a boy and color blue, it's equals to 19 out of the total, which is 126. So it's 126. So that is the probability of a boy and color blue, right? So, and if events are independent, then it means that the probability of a boy multiplied by the probability of blue must give us the probability of a boy and the color blue. So meaning this answer here must be the same as the product, this product here. If it's not the same, then the events are not independent. So let's check, what is the probability of a boy? Probability of a boy, these are boys, right? What is the total number of boys? It's 50. If you look at the contingency table, so 50 out of the total number of learners, which is 126, multiplied by the probability of the color blue. So this is the color blue, right? What is the total number of blue combining both boys and girls? So it's 60. So it's 60 divided by total number of students, it's 126. So the answer that you're going to get here, it's going to be equals to 0.18896, right? The product of these two here. But is this answer equals to the answer here at the top? This problem here, we have the probability of a boy multiplied by the probability of blue equals the probability of boy and blue. So if the product of the probability of the boy and the probability of blue is equals to the probability of a boy and color blue. Therefore, the events are independent. If they're not equal, then they're not independent. So what is the probability of a boy? It's 50 over 126 multiplied by 60 over 126 equals to. So the probability of a boy and blue is 9 over 126, and the answer to this section here is going to be 250 over 1323 equals to 19 over 126. So the left hand side is going to give you 0.18896. The right hand side is going to give you 0.1508. So as you can see, the left hand side is not equals to the right hand side. So therefore, the events are not independent. Okay, so this is question 12. An athlete associated, now we're doing question 12. An athletic association decided to host an athletic event. The following 12 male athletes were selected according to their personal best times for the season on a 100-meter sprint. So we're having 12 male athletes. So they're defined using these alphabets. In Northwest, there was an athlete A and B. In Gauteng, an athlete A, B, and C had their personal best times. And in Limpopo, we have A and B. In Mpumalanga, we have A, B, and C. In Free State, we have A and B athletes. So these are the 12 athletes that were selected according to their best times for the season. So no athlete had the same personal best times. There are 12 lanes next to each other in the stadium. So think of it as a track. So this, let's say this is a track. So remember that if this is a track, and then this is a lane of a track, right? Think of it as a 100-meter distance, and this is 1, this is 2, 3, 4, 5, 6, 7, lane number 7, lane number 8, lane number 9, and lane number 10, lane number 11, and lane number 12. So there are 12 lanes, so, and also 12 males. So please visualize. And then 12.1, if the 12 athletes are placed according to their personal best times from fastest to slowest in lane 1 to 2. So let's say, for an example, here in lane 1, so let's say, for an example, in lane 1, we have the fastest runner or athlete. Then as you go down, we go to the slower or the slow athletes, right? So yeah, just think of that. So if the athletes are placed according to your personal best times from fastest to slowest, from lane 1 to 12, independent of the province they represent. So you don't have to consider if they come from Northwest, Gauteng, Limpopo, Mpumalanga, or Free State. So just neglect the province. In how many ways can the athletes be placed? right? So if you only consider the best times, if you place these athletes according to the best times, and you say this athlete number 1, best time for a 100-meter race, for a 100-meter race, let's say for an example, the athlete number 1 takes 10 seconds, athlete number 2 takes 11 seconds, athlete number 3 takes 11 seconds, 0.5, athlete number 4, 11.6, 11.7, this one, 11.8, 11.9, 11.10, 11.12, 11.14, 11.16, 11.18. So let's say you place these athletes according to their best times, and these are the examples of the times that I've stated, and you neglect the fact that they come from certain provinces which are different. So, and then I ask you, how many ways can you place these athletes? You can only place them once, because you only, the critical point here, the condition is you have to place them according to their best times, and the best time here above all is 10. So the rest, the time goes slower, or you go from the highest to the lowest time as you go down. So for 12.1, you're only going to place the athletes one way. Fine. 12.2 says that the organizers of the event decide not to place the athlete according to their best times. So let's say, for an example, you now no longer want to consider this, placing the athletes according to their best times, but the organizers change. They say, but to place each athlete's name in a container. So let's say you have a container, and then you're going to place the athlete's name, A, B, C, whatever the name is. You're going to place the name in a container and select an athlete for each lane randomly. So you're going to select these athletes randomly for each lane, from lane number 1 to lane number 12. Remember that the number of lanes is 12. The A athletes from Mpumalanga and the A athletes from Gauteng do not want to run next to each other. So let's say an athlete from Mpumalanga is here. So we need to consider that. How many ways can the 12 athlete be placed next to each other so that athlete A from Mpumalanga and athlete A from Gauteng do not run next to each other? So I want to know the number of ways at which these athletes are going to run. But we know that there's how many athletes? N is equal to 12. That is the number of athletes, right? And there's 2 athletes that will not run next to each other. So this represents 2 athletes. This represents the total number of athletes, right? And then we want these athletes not to run next to each other. So you're going to say N, which is the total number of athletes, minus the 2 athletes, and then N minus 1 factorial. So this will mean that the athletes do not want. So the entire expression, this expression says that these 2 athletes will not run next to each other. Remember that N factorial is the total number of athletes. At 2 factorial, it is those 2 athletes that don't want to run next to each other. And then N minus 1 basically means that you do not, it's like saying if N is the last term, what is the previous term before N? It's N minus 1, right? So this is next to n, right? So it determines the position between n and the previous term, which is n minus 1. So hence this defines the previous term, which is n minus 1. So the entire expression says that the athletes do not want to run next to each other. So you're gonna say, instead of writing n factorial here, you're going to write the total, which is 12. So it's going to be 12 factorial minus the two athletes that don't want to run next to each other, and 12 minus 1 factorial. So the final answer for this problem is going to be 399,168,000. So this will be the answer that defines the placement of these athletes, taking note that there's two athletes that don't want to be placed next to each other, athlete A of Mpumalanga and athlete A of Gauteng. So 12.3. In how many ways can athletes be placed randomly next to each other if the two C athletes must run in the two outside lanes? From lane 1, it's either, okay, the outside lanes, it's the first lane or the 12th lane. The A and B athlete must run alternatively. So remember that we have athletes A and B and C, and we are told that in how many ways can this athlete be placed such that the athlete C runs in the outside lane. So remember that this is lane number 1. If let's say athlete C runs here and another athlete C runs here, taking note that there's only two athletes C from the given question. So if athlete C runs here and another athlete C, let's say this is C1 and this is C2, because these are two C athletes, they are not identical from each other. So let's say they run from outside lane. So which means in between it's going to be what? It's going to be athlete B, athlete so athlete B and athlete A. So it's going to be, so athlete A and B will run randomly, like they'll just run, they'll be placed differently, right, between C1 and C2. So it's going to be A, B, and 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 A, right? So they're going to be placed differently. Either be placed like this, or if let's say this is C2 and then this is C1, right? So meaning instead of writing AB, it can be BA, 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 BA. So the number of ways that the middle athletes will be placed is two ways. They'll be placed either in this way or in this way, right? So we need to consider that. So our answer here, so what we need to do is, there's two ways to place the C's, right? Either this way or this way. Two ways to place C's. And then multiply by, there's also two ways to place the A's and B's, either this way or this way, since they'll be placed randomly. So multiply by 2 times, and consider the factorial of the middle athletes. So how many A's are here? So 1, 2, 3. So let me use a different color. So there's 1, 2. Let me use blue. 1, 2, 3, 4, 5, 6. So there's 6 A's. No. Considering that we have 12 number of male athletes minus the C's, which are 2, we remain with 10, right? So if you remain with 10, it means now that in this 10, there's a combination of athlete A and athlete B, right? So that means now that if 10 represents athlete A and athlete B, it means athlete A, athletes of A are 5, athletes of B are 5. So these athletes will be placed differently, hence we put factorial. They'll be placed differently. So we're going to say 5 factorial multiplied by 5 factorial, right? Times. So the placement of these athletes will be ones. So remember that it's going to be AB, 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 AB. So we're just going to multiply by 1, and the answer to this question is going to be 57600. 600. So this is going to be your answer for 12.3. So now 12.4. At the end of the event, a fun run is held where only 6 athletes are allowed to run if the 6 athletes are chosen randomly. Remember that we have athletes A, B, and C, and there are a total of 12 athletes, but for this fun run, we only need 6 athletes. It can be A, B, or C. We don't really know. What is the probability that there will be only 1 athlete from Free State competing in the fun run? So remember that going to the number of athletes of Free State, there's only 2. So there's a possibility that it can be athlete A or athlete B, but not both. So only 1 athlete will be chosen from the Free State. So let's first find the probability of that. So for the Free State, we're going to say out of those 2 athletes, only 1 is going to be chosen, right? So it's going to be the 2 athletes out of a possible 6 athletes. Remember that we want 6 athletes. So P is equals to, so remember the question says, what is the probability that there will be only 1 athlete from the Free State running? So the 2 represents those 2 athletes from the Free State multiplied by the factorial of 10. So it's going to be 10 times 9 times 8 times 7 times 6. So what does this mean? We are having a factorial of 12, but we are removing 2 of those athletes who are separated, and so these 2 athletes are from Free State, and we only want 1 athlete out of these 2. So we're going to remain with 10, and if we remain with 10 factorial, we only want 6 athletes to participate. Hence, it's going to be 10 times 9 times 8 times 7 times 6, right? So we're going to divide that. So, but before we divide, we have to multiply by the total number of athletes that are chosen, which is 6, right? Then we divide by the total factorial, which is 12, right? But this 12 is going to end at 6 contestants. So it's 12 times 11 times 10 times 9 times 8 times 7. Remember, we only want 6 remember we only want 6 contestants. So hence we're gonna end at 7. Now The probability of us choosing one contestant from Free State is going to be 6/11. So this is the final answer. Thank you so much for watching. If you have any questions, suggestions, or comments, please write them in the comment section below. Don't forget to subscribe to the channel for more videos.